Hi, sorry I couldn't be with you guys today, but I'm running a field trip for my molecular biology course up to Precision for Medicine, which is in Frederick. So basically, watch this YouTube video, go through it. Mr. Kojal will be handing out all of the various handouts and see if you can figure out at least a little bit about molecular geometry and electron geometry. So we do have a warm up. So the objective is to introduce the concepts of negative charge centers and molecular and electron geometries and bond angles. So the first question is, what is the shape of a water molecule? Take a moment, write it out. Now, you may or may not know water is bent. It's bent because it has, at the oxygen, that's the center, it has 4 negative charge centers, 2 lone pairs and 2 bonded pairs of electrons. And they try to get as far apart as they can. Now we're going to talk about how this works in just a second, because I'm going to introduce the concept of valence shell electron pair repulsion theory. Okay? Valence shell electron pair repulsion theory. This is a definition. It's in the Quizlet. It's one of the ones you need to know. It states that only the electrons in the valence shell determines the shape of the molecule. So really, when you think about it, what can you have in the valence shell? Well, you can have, if you're a carbon, you could have 4 bonds. Maybe if you're a nitrogen, you might have 3 bonds on a lone pair. If you're an oxygen, if you're at the center of the molecule, you might have 2 bonds and 2 lone pairs. So anyway, all of the valence electrons that are on the atom that we're looking at the center of a molecule are going to determine the shape of that molecule. Now, what is an electron pair? There's 2 types, bonded pairs and lone pairs. Remember, they're made of electrons, right? So they're trying to get as far apart from each other as they can because they have a negative charge. Remember, a lone pair counts as 1 center of negative charge. A bonded pair, and actually it doesn't matter whether it's a single, double, or triple bond, it also counts as just 1 center of negative charge. And all the negative charge groups try to get as far apart from each other as they can. Okay, next, there's 2 aspects of the shape, that is the geometry of molecules. One is the shape of the molecule itself, and one is the shape of the valence electrons, the pairs of valence electrons around the center atom. So electron geometry means shape of all the electron pairs. Remember, electron pairs might be lone pairs and they might be bonded pairs. Molecular geometry means the shape of the atoms in the molecule, how they are arranged in space around the center atom. Now, what you're going to see is you're going to have this as a handout. It kind of shows you both number of negative charge centers, the number of bonds, so some of them will be negative charge centers that are bonds, and some of them will be negative charge centers that are lone pairs. It shows the electron geometry. It gives a partial Lewis structure to kind of show roughly what things look like just using A's and B's. And it will also give you the molecular geometry, including names. And it even gives an example with kind of a 3D sketch. This is one of the sheets that you'll have, and you'll need this to do sort of the basic molecular geometry. Key terms to recognize, right? The first is linear. That's the top one in your sheet. 3 atoms in a line. Okay, it also could be 2 atoms in a line, all right? Because 2 can only make a line. The center atom can't have a lone pair or 2 lone pairs on it, all right? If it doesn't, then you're going to get all the atoms lined up in a line, so it'll be a linear molecular geometry, and with no lone pairs, it's also a linear electron geometry. Okay, so there's an example. That could be beryllium with 2 chlorine atoms attached. The next is called trigonal planar. Now it's four atoms in a plane. They are at 120 degrees from each other. Yes, you are going to need to know names, and you're also going to need to know bond angles. Now, there's only one atom in the center. It has no lone pairs. So I'm going to give you two examples: boron chloride, or actually it's boron trichloride, or methanol. Okay, so let's take a look at what their shapes are. So the one here, that's a boron atom, and those are 3-chlorine. You can see if you were to measure, if that was a circle, they're 120 degrees apart because there's 3 angles. Here, that's the carbon of methanol. That's the oxygen, and those are the 2 hydrogens. Again, it's all in a plane, and they're 120 degrees apart. If you want to talk about electron geometry, the electron geometry is also trigonal planar. You're going to see that the molecular geometry and the electron geometry match whenever there are no lone pairs in the center atom. So we're looking at the center atom here, center atom here, center atom here, when we're describing the molecular and electron geometries. Tetrahedral. Now we've got 5 atoms attached, okay? 4 of them are attached to a center atom. They're all going to be at angles of 109.5 degrees to each other. So they're not 90 apart. They're not in a plane. It's 3-dimensional. There's no lone pairs in the center atom. This example is, say, 3-chlorine and a hydrogen. Okay? That shape is called tetrahedral. It kind of looks almost like a little pyramid in a way, with a triangular base. Here's another side view of it. So you can see it's like a little pyramid, and it's got a thing sticking up on the top. Okay, trigonal pyramid is the next one. This time there's only 4 atoms, okay? The bond angles are 107 degrees. The center atom has 1 lone pair. Examples would be PH3 or NH3. NH3 is ammonia, PH3 is phosphine. So what I did here is I wanted to show both the molecular geometry and the electron geometry. Now, do you notice here the center atom could be a nitrogen or a phosphorus, and you notice that there's a hydrogen, a hydrogen, a hydrogen around it. That could be NH3. There's also a lone pair right here on that center atom. Now, lone pairs tend to spread out and are pushy, okay? So instead of 109.5 degrees, you're going to end up with about a 107 degree angle. So in other words, all negative charge centers aren't equal. Single, double, and triple bonds all push the same amount. Lone pairs are space hogs. They kind of spread out and shove all the other like bonded atoms closer together. If you were talking about molecular geometry, trigonal pyramid is what the shape of the molecule is. But if you look, there's 4 groups of negative charge, one of which is a lone pair around the center atom. So that makes the electron geometry tetrahedral. Okay, next is bent. So 3 atoms, but the center atom has 2 lone pairs, for instance, in water or dihydrogen monosulfide, with angles of about 104.5 degrees, or 1 lone pair, something like, let's say ozone, which would have 1 lone pair of the oxygen in the center, and it'll bend it a little bit to be about 118 degrees. Or maybe sulfur dioxide, which also does the same thing. So here's an example. Here's water. This is water. Oxygen is the red. The 2 whites are the hydrogens. No lone pairs are shown on the oxygen in the left diagram. In the right picture, you can see there's a lone pair here and a lone pair there. Those lone pairs spread out. Now, here's a good rule of thumb. A lone pair decreases the bond angles by about 2.5 degrees. Now, do you remember, if it's tetrahedral, they'd be 109.5 degrees apart. Water has an electron geometry that's tetrahedral. The molecular geometry is bent. So from the electron geometry, we can figure out the angles because the lone pairs are very pushy, and there's two of them, and each pushes down about 2.5 degrees. Instead of the angle here being 109.5, it's about 104.5. Okay. What about this weird looking thing? Sulfur hexafluoride. So it has an octahedral molecular geometry, and all bond angles are 90. Now, I've shown some of these in class, kind of these weird shapes that I've had built. So this is just a picture of the same thing. Another one that is a little odd is PCl5, which is a trigonal bipyramidal molecular geometry, and has bond angles of 90 degrees and 120 degrees. Now, I want you to realize there's no lone pairs in the center atoms here. So the electron geometry is identical to the molecular geometry. Now, not only do you have to be able to memorize all the shapes and the names and the angles, we also have to have some sort of a process to figure it out. The process is draw the correct Lewis structure first. Why? Because you're going to need to look at that center atom of our molecule and find out how many bonded pairs and lone pairs it has. We identify the number of lone pairs and bonded pairs on it. All lone pairs and bonded pairs try to move as far apart from each other as possible. Sorry, yawning. That's what valence shell electron pair repulsion theory states. And by moving as far away as possible, that's going to determine the shape. The electron geometry and molecular geometry are identical if there's no lone pairs in the center atom. If the center atom has lone pairs, they will not be identical. Okay? Now, this will be something that I'll probably go over again when I get back, how to draw 3D molecules or make a 2D sketch of a 3D molecule. A wedge means, a solid wedge means it protrudes towards you. If it's going away from you, it starts out broad and gets smaller as a dotted line. And then just in the plane of the paper is just a normal solid line. So to try to give you an example, let's take a look at water. That's what water would look like. Now look, this hydrogen and this hydrogen are solid lines. They're in the plane of the paper. The center atom is our oxygen. You've got two lone pairs. One is a wedge coming in front of the paper, and one would be kind of a dashed wedge getting smaller. That means it's behind the paper. So here are some examples. Now there are slight variations on how to draw them, but in these examples, A's and X's are atoms, E's are lone pairs of electrons. So it gives you an idea of how to draw some of these shapes. Now your homework is that worksheet, and don't panic about trying to work on it in class tonight, because guess what? It's a no homework night. We'll work on it in class tomorrow, okay? And so we'll also be working with the model kits tomorrow to try to figure this stuff out. There's also, besides that first molecular geometry sheet, Mr. Kozel is also going to hand out this other sheet that shows things like the trigonal bipyramidal and the octahedral molecular and electron geometries, just so you get a chance to see them. And that is pretty much it.